These are the log equations that were on the quiz. And I want to go over them with you just sort of quickly to try to make sure that everybody knows how to do them. Log base 4 of x plus log base 4 of x plus 6 is equal to 2. Okay? Just for the purposes of trying to make something clear here, if these two sides are equal, then I can use them as exponents. And I can say, let's raise 10 to the power of log base 4x, or actually even better, let's use 4, since that's what we're doing, right? Raise 4 to the power of log 4x plus log 4x plus 6, and that's going to be equal to 4 to the second. Okay? Now, we know that a to the m plus n is equal to a to the m times a to the n, right? So that means this is really 4 log 4x plus, or times, rather, right, times 4 log 4x plus 6, and that's equal to 16. Does everybody understand what I just did? No? Yeah. So basically, without having to use laws of logs at all, just using laws of exponents, I now know that x times x plus 6 equals 16, because 4 log 4, 4 log 4, like that, well, this is what that means. So x squared plus 6x minus 16 equals 0. That means x plus 8 times x minus 2 equals 0. And that means x is equal to negative 8, and x is equal to 2. Now, here's a question. Ten raised to the what power is equal to negative 8? Right? And so the result of that, since there is nothing you can do here to get a negative 8, that means the log base anything of negative 8 doesn't exist. Okay? That's what this says right here. When you say this doesn't exist, that's what you mean. That means if I plug in negative 8 for x way up here in the original thing, I've got something that doesn't exist, so this can't be a solution. This is the only solution to that problem. Okay? I'm not going to do that same level of craziness with every one of them, but here, log base 6, x squared minus 1, minus log base 6, x minus 1 equals 2. This subtraction means division. X squared minus 1 over x minus 1 is equal to 2. And I can reduce this. Log 6 x plus 1 is equal to 2. But I have to put over here, just sort of as a notation, x can't equal 1. Even though if I plugged 1 in here, that'd be okay. If I came from here where x minus 1 was in the denominator. So I can't put x minus 1 as a solution anywhere, or x is equal to 1 as a solution anywhere. Okay, So let's see what else we got. So we're going to raise both of these sides as a power of 6. So that makes this x plus 1 is equal to 36. X is equal to 35. Questions about any of that? Those were the two problems on one version of the test. The other looked like this. Log x plus log x plus 21 is equal to 2. And so this means these are being multiplied. Log of x squared plus 21x is equal to 2. I'm going to raise 10 to the power of both of these. That makes this side x squared plus 21x is equal to 100. X squared plus 21x minus 100 equals 0. X plus 25 times x minus 4 equals 0, which means x is equal to negative 25, and x can be equal to 4, except that this can't be equal because we go back up here, and that would make this log of negative 25, and that can't happen. So the only answer to this is x is equal to 4. And then finally, we have log base 3 of 2x plus 4 minus log base 3 of x minus 5. All of that is equal to 2. Okay. This means there's division happening here. Log base 3 of 2x plus 4 over x minus 5 is equal to 2. Now we're going to use those two numbers as exponents for 3. That makes this part go away, so it's 2x plus 4 over x minus 5 is equal to 9, which means that 2x plus 4 is equal to 9x minus 45, which means 49 is equal to 7x, which means x is equal to 7. And that's the answer to that one. Anybody have questions about that? Everybody's okay?